Hello, this is Steve from ObjectRiver. A couple announcements. First is ObjectRiver is an OpenAPI implementer. But more importantly, ObjectRiver is the first OpenAPI implementer to deliver WebSockets across 3 platforms. We have Angular 6 as a client. We have Java client and server. And we also have a Node TypeScript server. So here's the backstory on WebSockets and ObjectRiver. In 2014, ObjectRiver implemented WebSockets, client and server for Java. And we announced that at Java 1 in San Diego in 2014. At the time, JavaScript really didn't have reliable WebSockets. They didn't have any WebSockets interfaces. They had unreliable socket differences between the browsers. And also at the time, people were saying that the internet proxies couldn't totally handle, WebSocket traffic. So at the time, we didn't implement a JavaScript version. So more recently, what we've done is we've found that there are a couple really good WebSocket implementations for TypeScript. The first one we really like is RxJS, and we're running that in Angular 6. On the Node side, we're using Node WebSockets, and we've got a TypeScript server implementation for Node. So again, this is what we've been doing. We're announcing, OpenAPI, WebSocket implementation, 3 platforms, Angular 6, Java client and server, and Node, TypeScript Node server. Also, you see these demos with our cloud compiler. Our cloud compiler is written in WebSockets, and we've been running that very successfully over the internet for the last 5 years. So enjoy the demo. Okay, we're going to start our demo by using IntelliJ to open one of our sample projects. This is a Java project. It's in our REST toolkit. So we're going to open our developers example here. Now this has opened an empty project for building REST web services, and we ship 2 models. They're both identical. One is the OpenAPI model, and so this is an industry standard. It's very verbose in describing, web services. We also ship the ObjectRiver model, a little more readable. It basically follows like a JAX-RS format. If you look at these definitions, these are equivalent to annotations in JAX-RS. Because we need to generate the server side, we've got to convert one of these models to the WebSocket IDL. So this is kind of like a hybrid type solution. So I go up here and I'm going to create what's called a run configuration. And this is the cloud compiler. We ship this in the toolkit. This is a plugin that goes into IntelliJ, WebStorm, kinds of tools. So I'm just going to call this WebSocket. So first this is a REST metadata, and I want to generate the metadata for WebSockets. So I pick this, and I select the model. So this is the open architecture model. I give an email. I want to build, so that's that. And then I run this. This is going to generate WebSocket metadata for the server side. That reached out to AWS, and it generated this metadata right here. Looks very similar to the other one. And here are the WebSocket REST web services. We also generate this callback include here. This is kind of empty, but we'll be describing that in other videos, the callbacks, because WebSockets is a totally bidirectional implementation. So I'm going back up to here to create another run configuration. I'm going to add this, but I'm going to say, let's just say Java WS. That's the name. And I'm going to say I want WebSocket IDL. And I'm going to generate Java. I'm going to generate client and server. I'm going to pick the model. This is this model for develop. Again, enter an email. Turn off the build. We're going to put this in the Java directory because we're going to put Angular in the source directory here. And take that. We're going to generate. I generated all the server code for implementing all these requests. And on both sides, we do mocking. So this will reply with mocked answers. You'll see when we get to the Angular side. There's a little bit of housekeeping we got to do in IntelliJ. And the source is I put the source in Java and not in the source directory here. And then we generate the dependencies, but you still got to select them. So we generate these library dependencies, and you have to select them for IntelliJ to work. The other thing we generate is we generate an ant build, which is right here. And you want to run this to generate the var and create paths, etc. So what that did is it generated this var file. One thing you'll notice is there's a hash mark, and WebSockets uses kind of the var definition as a partial path. So the next thing I can do is I can go into here and go to this server, and I can run this server. Now there's no web server here. This is actually a Grizzly server. So it's all can be run within the IDE and you can debug it directly. So that's running. Now we'll go to our next part of our demo. Okay, now we're going to set up our Angular project. We're going to do this by executing a CLI command called ng-new developers directory./ So this is going to, using CLI, is going to create all the necessary files for the Angular project. Okay, now that that's completed, we're going to install another package. This package is called JSON to TypeScript. This allows the marshaling of TypeScript classes to and from the server. Now we're going to install this date picker. The reason I'm using a date picker is this specific date picker will create JavaScript native dates as opposed to strings. So now in your TypeScript classes, if you have dates or timestamps defined, the date picker will populate them correctly. This date picker is dependent on the Angular CDK. You're seeing some of these version numbers like 6.3. I'm running in Angular 6. And so these are the specific versions for these dependencies. I'm also going to bump the version of TypeScript. I think this is the kind of the latest version for Angular 6. And all of these packages are defined in the package JSON in Angular. And we also have them in our release notes. So if your system is slightly off, you can adjust it. In some cases, part of programming Angular is just figuring out all the correct releases of the open source packages you need. So that's it for configuring Angular. Okay, let's continue our demo and let's generate some Angular code for WebSockets. I'm going to go back up here to a run configuration. I'm going to clone one of the existing ones we did. We'll just call this WS Angular. Come over here. Now we have a REST. We're going to use our REST compiler, and we're going to generate Angular for WebSockets. Again, this is our model, OpenAPI architecture. We're generating to the source directory. And so that's all it takes to create a run configuration. Now we'll run the compiler. So now this is reaching out to AWS. Our compiler is written in WebSockets, and now it's going to generate all the code. Another thing to mention, our system is totally free. We generate all the code. If we happen to ship a library, in the case of Java, we ship a small library that has source included. So you're a complete full source solution. All right, so I've generated the code. You can see a lot of this is just straight up Angular code with services and HTML and all TypeScript. So now let me go to a terminal and I'm going to execute ngserve. This is Angular's way of doing a compile and displaying the application in your browser. So now it's compiling and it's telling us that it's going to display this on the local host 4200 port. Okay, so that compile was successful and now the application is running. Let me bring the browser over here. So here's the browser. Let me hit F5. Let me go full screen. What I'll bring up the debugger to it. Whoops. Okay, so what you're seeing is basically the documentation for the application. And this shows the web service, and it kind of is in the, the JAX-RS annotation. If there was a bean or a dictionary, there's links here, and that will go to the basically the bottom of the page. Surprised that's taking that long, but here are the beans, and there's an enumeration, and these are back to your web services here. So so any of these can be invoked, and it brings up this screen, which is like a JSON-like screen where you can add different data for input. So this is the input. If I execute this, that went out to our server. Now remember, we started the server. Let's just go back over here and look at our server. I can find the server. There's the server. And it just printed out inside the bean method here. So we go back to our browser. I can hit the back button. And we can execute. Let's pick one that's a little more interesting with the output. There's a bean list. Okay, this is our stuff bean. I can fill in, information here. This is where we added a date picker. And what we did was we used the ng pick date time. And the reason we did this is this will create a native JavaScript date as opposed to the default, which creates a string, and that complicates your classes. So that's why we included the ng pick date time open source module. So here I fill out the data, I do send, and what that did was it basically did a round trip. So it went out and then it returned the same structure. This was a list. So that's basically it. The way I'm not going to get into the code, but those are for later videos. But what happens is we've built an API layer, and that API layer allows you to do REST or WebSockets. It's the same API, and it's uncoupled. So that means you can take that API library that's all TypeScript, and you can put that in your application without these test screens. So that's our OpenAPI demo for WebSockets. Again, ObjectRiver is the only OpenAPI vendor shipping a WebSockets product. This runs Angular client, Java client and server, and we have a Node TypeScript server also. So thanks for watching.